Pollution is one of the main causes of biodiversity loss. Water pollution is a major threat to protected areas, which are exposed to contaminants through rivers and other channels connected to surrounding agriculture or industrial areas. Spain's Doñana National Park, famous for its great ecological diversity, is classified as a biosphere reserve by UNESCO. Farming activity that takes place around the park poses a threat due to pesticide and fertilizers that could easily be brought into the marshes. When unforeseen events occur, it is necessary to obtain data more often or more accurately than usual, and as quickly as possible. Among the biggest challenges facing data collection is the rugged nature of Doñana's terrain, especially during the rainy season, when much of the marsh is flooded and difficult to access. In the Planet project, we developed a system formed by a cooperative network of heterogeneous sensors, both fixed and mobile, which may be able to improve water pollution detection and monitoring. Unmanned aerial systems, or UAS, enable observation of otherwise inaccessible areas, offering real-time data at high resolution. Images taken by onboard cameras are geo-referenced and can be used to build map mosaics that serve to detect anomalous pollutants over the surveyed area. Since Doñana's marshlands flood in the rainy season, it is difficult to install permanent sensor stations and to recover the information they collect. One solution is to deploy sensors with a UAS. These sensors are programmed to self-organize into clusters, which each have a single head. Once a large group of nodes has been distributed, each cluster head collects the measurements from all the other nodes and securely transmits the data to a UAS, which then transmits the data to a ground station. Another method for data collection are unmanned ground vehicles, or UGV, which can be dropped at the sensor site by a UAS. They use GPS navigation to collect the node's data, sending them to a base station in real time. In addition, an onboard streaming camera can provide live video, helping researchers to better understand the conditions of the surrounding environment. When all the data has been collected, the UGV can be automatically retrieved and returned by a UAS. In the case of a pollution event, researchers need to take water samples from the affected sites. We collected water samples with a water pump-equipped rotary wing UAS, which flew autonomously to the target area. With the samples in hand, field researchers can study the chemical composition and source of the pollutants. All the information from fixed and mobile nodes is combined into the Planet platform, which offers an integrated approach for efficient cooperating objects network monitoring and control, and covers various features, including network diagnosis, healing, and management, to ensure the integrity of the deployed network. Protection of natural areas requires intensive, flexible, and effective monitoring. The collaborative efforts of multinational research teams, combined with inventive applications of burgeoning aerial technologies, is creating a template for the future of environmental monitoring and protection.